Hello students, so today's topic is vector subspace. The theoretical part is already covered. We are going to the problematic part and it is one of the important questions and you can expect the question. So there are three rules that you have to follow when solving for the problem. The first rule is about the containment of the zero vector. So what is that? So if the zero vector is not in the subset, then it cannot be a subspace because vector spaces must contain the zero vector. All right, so the second one is the closure under addition. So it means that for any two vectors, say u and v in the subset, their sum, that is u plus v, must also be in the subset. All right, so must also be in the subset, that is and addition. Now the third one, that is closure under the scalar multiplication. So what does it mean? We have to verify if the subset is closed under scalar multiplication. So for any vector v in the subset and any scalar c, the scalar multiple c into v must also be in the subset. All right, so it belongs to the w. Now let us dive into the problematic part. So this is the first this is the first question that we are going to solve. We have to check whether w is equal to a plus 2b and whatever the vector they have given is under the subspace. So what is the first rule? We have to check for the zero vector. So let a and b is equal to 0. Substitute where it is 0. So a plus b, 0, sorry, a is should be 0, right? So both are 0. 3 into 0 and you get a vector that is of the 0 form, 0 0 0. So that is 0 vector, therefore it belongs to w, that is a subset. Okay, now the second one is what? Second one is scalar addition, right? U plus v is, okay, let me take u. So what is u here? U is equal to two vectors we need for u and v separate, so that is why u is equal to a1 plus 2b1, a1 minus b1, 3b1, that is u. What is v? V is equal to a2 plus 2b2, a2 minus b2, 3b2. Now we have two vectors, we have to add these two vectors. U plus v is equal to a1 plus a2 plus 2 b1 plus b2. Next, a1 plus a2 minus b1 plus b2. Okay, next 3 b1 plus b2. Now what we have to do is we have to take the assumption as a1, let a is equal to a1 plus a2 and b1 plus b2 is equal to b. Okay, now substitute back. What you will get, it is a u plus v, that is a plus 2b, a minus b, 3b. All right, so I got the same vector, so I can clearly say that it belongs to w. Now the third condition is multiplication, that is scalar multiplication, c into u. So what is c into u is equal to c a1 a1c, or anyhow 2 plus 2b1c, then a1c minus b1c, then 3b1c. Now let me take the assumption, let a is equal to a1c and b is equal to b1c. So what is the vector I will get? It is a plus 2b, a minus b and 3b. Again we got the same vector and it belongs to w. So therefore the equation w belongs to the subspace. I hope you understood this. Now let us see one more example, the second example. So determine whether if the following sets of vector are in the subspace and you check whether x is equal to y square. Okay, the first and foremost thing, 0 vector 0 comma 0 is equal to 0 square, which is 0 again. So I can say it is a 0 vector, it belongs to Q subset. Now second one is the it is addition. So it is nothing but u plus v, right? So let us take two vectors, x1, u is equal to x1 y1 and v is equal to x2 y2. So meaning what I can write, it is nothing but x1 is equal to y1 square and x2 is equal to y2 square. So now consider the sum x1 u plus v, that is x1 y1 plus x2 y2, which gives you x1 plus x2 comma y1 plus y2. Yes. Okay, since x1 is equal to y1 square and x2 is equal to y2 square, x2 is equal to y2 square, we have x1 plus x2 is equal to x1 square plus y2 square, right? However, this sum doesn't necessarily satisfy the condition, that is, the condition is what, x is equal to y square. So it doesn't satisfy the condition x is equal to y square unless and until if y1 is equal to y2, right? If it is y1 is equal to y2, only then I will get x is equal to y square. So I can clearly say that whatever the statement they have given, it is not closed under vector addition, not closed under addition or vector addition or q. All right, now let us check for scalar multiplication. All right, scalar multiplication. So what is the formula? That is c into u or c into v, right? C into v. So let's take the vector x into y in w, meaning x is equal to y square, x is equal, okay, cx into cy. What does it mean? It is nothing but you get cx is equal to cy the whole square. So if I take the assumption that let cx is equal to a or x, or cy is equal to y, if I replace x is equal to y square, so I can say that it is closed under scalar multiplication. Yes, is closed under, so scalar multiplication is closed under the q. Yes, and but I have to write the whole assumption, because there is one thing that is not it was not included. So we failed for scalar addition property, so I can say that it is not a subspace of R square. Okay, not a subspace, because one condition has failed. So I can say that addition and whole as a whole, it is not under the subspace of R square. That is all. We'll continue in the next class. Thank you.